Do you ever talk to your phone or your smart speaker and just wonder how it gets you so well? It's not magic, of course. It's deep learning. But human speech is incredibly complicated. So let's dive in and really unpack one of the key pieces of tech that makes super accurate speech recognition actually possible.
Okay, so let's start with the big problem, right? Why is our speech, something that's so natural for us, such a huge headache for a computer? Well, it really all boils down to one critical idea. And that idea is ambiguity. Think about it for a second. The exact same tiny little sound, a phoneme if you want to get technical, can mean totally different things. Its true identity is completely tied up in the sounds that surround it. Context is, quite literally, everything.
So, for a machine to have any real chance of getting what we say right, it can't just listen to one sound at a time. It needs the whole picture, the full context of the entire phrase. And that's where the technology really comes into play.
All right, so let's start with the standard approach. We'll call this looking backwards. The tool for the job here is something called a recurrent neural network, or an RNN. And it's actually a pretty great place to start, because it's designed to handle sequential data, just like speech. So, why are these RNNs a good fit for this job? Well, first off, they're literally built to process information that comes in a specific order, just like words in a sentence. And second, they have a kind of memory. This lets them use what they've already heard, the past context, to help figure out what sound is happening right now. But, and this is a huge but, there's a big catch. A standard RNN is kind of like reading a book where you can only see the words you've already passed. It has a one-way street view of the world. It only looks backward, and that creates this massive blind spot.
So what's the fix? Well, what if we gave the model the power to see the future as well as the past? And that brings us to the real solution, looking both ways, with the star of our show, the bidirectional RNN.
And this comparison just lays it out perfectly. A standard RNN processes your speech from start to finish. A bidirectional RNN does that too, but at the same time, it processes your speech from the end all the way back to the beginning. So it's getting information flowing in both directions, from the past and from the future.
Now, this two-way street approach gives us two huge advantages when it comes to automatic speech recognition, or ASR, which all leads to much better accuracy. Let's break down exactly how.
The first one, and you could argue it's the most important, is that it directly fixes that core problem we started with, ambiguity. By getting access to what's coming next, the future context, the model can make way smarter guesses about what it's hearing right now.
So, how's that work, really? Well, by looking at the entire neighborhood of sounds around a particular phoneme, a BRNL can clear up confusion. If it hears a sound, it can peek ahead to the next sound to help confirm its guess. This just slashes the number of errors you get from similar-sounding words.
Okay, the second big win is something called improved feature learning. Now, I know that sounds a bit technical, but the idea behind it is actually really powerful.
Because the model is getting a stream of information from both directions at once, it builds a much richer, way more detailed understanding of the speech. This seriously boosts its ability to learn the super complex patterns and rhythms of how we talk, and that leads to a much better internal picture of what you're saying.
And hey, you don't have to take my word for it. As we can see right here from the source material, these two benefits, clearing up ambiguity by looking at future context and improving feature learning, are precisely why bidirectional RNNs are such a game changer for speech recognition.
So what does this all add up to? What's the big impact? Well, looking both ways is so important because it finally gives the machine a complete picture of what's going on.
This quote from the source really nails it. The enhancement comes directly from pulling in information from both directions. It's not just about getting more data, it's about getting a fundamentally smarter, more contextualized view of that data.
So here's the bottom line. A standard RNN is trying to understand a movie by only watching the first half. A bidirectional RNN gets to watch the entire film, right up to the credits, before it has to make its final decision. It gives the machine the whole story.
And that leaves us with a really interesting question to chew on. We've seen how looking into the future can crack the code on speech ambiguity. So where else could this idea of using both the past and the future to understand the present help us solve other really complex problems?